Grammar is made up of 4 tuples: variables, terminals, productions, and start symbol. Interesting. Let's start. Now, today's class, we try writing the grammar. Similar to how we wrote regular expressions, we try writing the grammars. First grammar is this. Write down, write a CFG to generate the language of A's and B's, starting with AB. Okay, so hope you have copied the question. Question says to write a grammar to generate the language of A's and B's, starting with AB. So the string should start with AB. So you can say the strings accepted would be AB, ABB, ABA, ABB, ABAB, ABBA, and so on. Is that clear? Start symbol is a symbol from which the grammar starts. Okay. Similar to DFA, NFA, where we had initial state, similarly we have initial symbol now. So that is called as yes. The question may be there, is it required to use yes always? Not necessarily. It might be any symbol we can use. But preferably we go for yes to indicate it as start symbol. And it is not mandatory to use yes. Anyhow, as of now, I may go for using yes, but in maybe some other grammar, I may change some other symbol as well. So now, as I said, it should start with yes. I just say yes is a symbol. This is a production symbol. Already I have told you. This should be there. Minus followed by greater than symbol, the arrow mark. So now, what is the minimum string to be generated? Minimum string generated is AB. So I can say yes generates AB, or yes can be replaced by AB. What should be there after AB? It might be A, it might be B, it might be A and B in any combination, it might be A and B in any number or in any count, isn't it? That means once you encounter AB, whatever following AB doesn't matter for us. It might be A, B, any number of A's and B's in any fashion. Is this clear now? Yes can be replaced by AB. This will generate AB. One string it is generating. But now we need to move forward to understand what should be there after this. So AB are terminals. Hope you can able to understand what is terminal now. Terminals are those symbols which are end symbols. So now when you talk about this AB, next after AB that should be a symbol that would generate A's and B's in any fashion, recursively, or I can use the word recursively. So what I do, I just use a word, I just use a non-terminal A. Okay. Now what is A? A can generate A or in turn generate A itself. Why do I write this? Please do understand. I can say A generates A or A can be replaced by A's, lowercase a, agreed. Then it will be ABA. What I need to do if it is continuous? If it is AB, something like that. So there should be something which keeps repeating. That something keeps repeating is uppercase A here. So I've written it as A can be replaced by AA or A can be replaced by BA. Hope you got it now. See, first two symbols are AB, no doubt with that. The third symbol should be either A or B. So I've written it as OR. But if you have only, suppose you need to end it. Now, how do I end it? I need to write it as epsilon. So, when I try to write the grammar starting with AB, that should be written it as S can be replaced by AB is fine, followed by uppercase A. When I say followed by uppercase A, that is a non-terminal. The non-terminal A can be replaced by either A or B in any combination. So I write A can be replaced by AA. So that uppercase A indicates repetition. You can keep on repeating. You can say A can be replaced by A can be replaced by A how many ever times you want. At the end, you can replace the A with an epsilon. Clear? So now, when you talk about this part, this is what the grammar we need to just understand. But I want you to make sure that you are able to understand this. Observe here. So I have written A. This A can be replaced by A. Fine. You can write this also like this. A can be replaced by A. This also can be written on the show. What I wanted is that A is getting replaced by lowercase a or uppercase a. So other production what I have written is A can be replaced by BA. I have written epsilon because you know at the end we need to have only terminals. If you keep on replacing A by AA or BA, you will be left with uppercase A at the end. So I need to replace it something, right? I want only terminal. So what I do, I just say replace A with epsilon, first option. Second option is second reason is once you get the actual string what you wanted. So suppose you wanted ABBA, then you replace S can be replaced by ABA. A you get replaced with BA. Again, uppercase you replace with AA. You have got the string now, ABBA, but you have one more unnecessary non-terminal A. I should replace that with something, right? So for that purpose, I use A. Now, rather than writing these three productions, I can also combine this. A can be replaced by AA or BA, or you can write like this as well. Let's go for next problem. So we wrote it for S can in starting with AB. Now we go for writing ending with AB. Language of A's and B's ending with AB. Again, it's better to list out the strings and then move forward. If you are comfortable, no sir, I can manage without writing strings, that is also not an issue. But I personally request you to write the strings before you accept it. S can be replaced by AB would remain same. It is S can be replaced by AB. I think I told you already that writing strings is required because sometimes if new grammar is given, not only for grammar, even for regular expressions as well as DFA, PDA or derivation, we expect you to write a set of valid strings because that would list out what are the strings to be accepted, first thing. Second thing, you can make sure that whatever strings you have written and the grammar what you have written would accept it. So that you can proudly say, yes, sir, whatever strings what I have listed, those strings are accepted by the grammar, which would be having all possible combinations. Start from minimum, then keep on adding one symbol by other symbol. You to say if the minimum string is two symbols, write first two, then you write three symbols, the combination, four symbols, the combination, fifth symbol, the combination. This part would remain same. No change in this. I just move with, hope this is clear now. I just move third problem. Same thing what we have done earlier also with substring AB. So substring AB, I can say all this is accepted. When ABA is accepted, ABB is accepted and so on. Yeah, I copy the same. Remember when I say substring, only thing I need is AB. And remember AB can be either at the beginning or at the end. For that purpose, what I write, S can be replaced by A into say uppercase A, lowercase AB, uppercase A. S can be replaced by A, ABA. Yeah, before moving on for the next problem, it's better you should know how to write grammar as well for the given question. Say for example, you have written the grammar for A can be substring AB. This is how I do it. This is the way in which you're supposed to write it. Anyhow, forgot to tell that, not an issue. So you should identify what is variable, what is terminal, what is production, and what is stat symbol. So variables are also called as non-terminals. So there are two non-terminals, S and A. Terminals are the sigma, what we are accepting with AB. Productions are what we have listed. I repeat, suppose if the question is asked for 2 marks, maybe if in a 10 marks question, if you have 5 grammars to write, then you can just write the grammar and leave it. Suppose if the question is asked for 5 marks, we expect to write this tuples as well. So that you are aware of what are the symbols and what they represent. The question will be still arise for some people. Why will I write all these things? Why should I write grammar? Very simple. Say suppose, as I was discussing the last class, say suppose you are developing a compiler, you should specify how an expression should look like. You are supposed to specify how a looping statement should look like, how a repetition statement should look like, or how array declaration should happen. For all those things, you should specify the rules. How do you specify in terms of grammar? There is something called as Dacker's norm form. Dacker's norm form is one such type of grammar where that is usually used to develop a compiler for most of the languages, Pascal, Fortran, even for partially for C and all. Fourth one, write a CFG to generate the language starting and ending with same symbol. So sigma is 0 and 1. So what are the strings accepted? I say strings should be 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, and so on. What is the minimum string? It is 0, 0. What did I tell? Starting symbol and ending symbol should be same. Is it not? 0, 0. It is starting and ending. So what should be there before this? It can be anything. That anything we represent it using uppercase C. A can be replaced by 0A or 1A or epsilon. Same thing I can repeat for endings, starting and ending with different symbols. See, if it is starting and ending with different symbols, it should be 0A1, 1A0. I will leave it to you people now to just check with this and understand it. See this, let us CFG to generate the language A's or A's and B's with at least 3 consecutive A's. You just go through 6th and 7th, I'll explain 8th one. I'll give 5 minutes, you just go through 6th and 7th. You want me to increase the font size or is it okay? Is it visible? I think you can zoom it, right? Once you understood 6th and 7th, or if you have any clarification, to let me know in that. We will discuss. Yeah, because it is saying 3 consecutive years. 3 consecutive years may be anywhere. It might be at the beginning, might be at the end, or somewhere. Fine. Suppose if the question was generate a grammar to accept the language of A's and B's with at least 3 A's. I am removing consecutive. At least 3 A's. Then it will change. So it will be somewhat different because I'm not making it consecutive. So then it may change. Check with 7th one. 7th one is pretty different, somewhat different. It says generate a grammar to accept the language. Sorry, write a grammar to accept generate the language of A's and B's with at most 5 B's. See, and 5 B's need not be consecutive. I'm not telling it to be consecutive. So I may make all these combinations now. If it was consecutive, it was similar to the maximum previously. And you may ask, why did I go for this OR operation? See, in the 6th question, it is at least. So minimum string is A. Got it? But since this question number 7 talks about at most 5 B's, maximum it is 5B. Minimum it might be 0A, 0 base or 1B, 2B, 3B, 4B or 5B. So maximum is 5. Since maximum is 5, whenever it is maximum limit is given, we try to write all possible combinations. We cannot generalize. So we need to write the possible thing, all possible. So for that purpose, I written like that. Anyhow, say question number 7, it is, see, what I'm telling. When you say it is at most 5 B's, you have 1 B here, you have 2 B's, you have 3 B's, and so on. Up till you have 5 B's here. You cannot have more than 5. That's done. What about A? A, we are not worried. You will be having any number of A's. Since we are not specified the condition for A, I put it as X. That becomes recursive again. X keeps on repeating X keeps on repeating. Accordingly, you can able to write it. Okay. Yeah. I leave these questions for you to understand 9 and till 10. Okay, I'll explain 10th one. I leave 8th and 9th for you people. I don't explain. Let's see how many will understand it. I go for 10th. 10th is somewhat different. Once you understand 10, you can able to solve all these problems. All 11 to 17, whatever is there, you can easily solve. Observe here. Question number 10, you simply observe. Write a CFG to generate the language L equals A power N, B power N. See, this was not able to write it for your Automata, DFA. So this is the language generated by the type 2 grammar. So now we try writing PDA to accept it. Okay. So now how do I make it understand? Observe properly. Now when you talk about this, what are the strings accepted? It says A power N, B power N. If it is A power N, B power N, obviously it is A's followed by B's. And it says number of A's and B's is indicated by N, where N value of N is greater than or equal to 0. When N is equal to 0, that means there are no A's and B's. That is epsilon. Epsilon should be accepted, followed by AB. AABB, AAABBB, AAAABBBB, and so on. Now, when I talk about this, I need to observe properly. First symbol is, sorry, first string is epsilon. I leave it for a while. I can say S can be replaced by epsilon and stop it. Moving on, next string is AB. Next string is AABB. That means you can say A's and B's are equally expanding, equally getting expanded. A is also getting expanded, B is also getting expanded. So what am I doing? Rather than using some other symbol, I can just write A can be replaced by ASB, where S acts as a midpoint. Again, if you want two more A's, I can just write A can be replaced by ASB, mid S you replace with again ASB, and so on. You keep on expanding. Remember, when you say A is increased, B should also increase. That's the question it says. It is A power n and B power n. It is n number of A's, what are the n number of A's? You cannot get a string like AB. AB, agreed it is number of A's and number of B's are equal. But I wanted always A's followed by B's. Because of that reason, I cannot consider AB as a valid string for this. Since the question is A power n, B power n. Instead, if I say it is A power n, B power n, the strings could be A, B, B, triple A, triple B, 5A, 5B, and so on. Clear? Hope problem number 10 is understood.